I think we gave it a good minute or two last time, just because people, you know, a little bit of time delay.
Yeah, wait till the time that it starts to actually log in, kind of thing.
Yeah.
Yeah.
So.
I still haven't hit the bottom of this coffee yet.
Yeah, I'm in the same boat, man. I grabbed a fresh cup and.
Yep.
See, Clinton, where are you at, actually?
Buffalo, New York.
Oh, okay. So you're a little ahead. You're 3 hours ahead, 4 hours ahead.
Yeah.
Something.
No, this is my midday, which makes it even sadder that this is my first cup of the day. But time doesn't matter right now, right?
You know. You get to a cafe and everyone's waiting on you to repair the coffee machine, and you're thinking, "Hey, where's my cup?"
Yep. I try not to do that, but sometimes they get me.
Yeah. Well, I'm in Spokane, so I'm on the West Coast, and it's a bit cold outside right now.
Yep. It is starting to get that way here too. My workshop is an old car garage, so there's not really a seal on the space at all.
Oh.
There's
yeah.
a giant furnace hanging from the ceiling over there that every time it turns on, I'm like, thank you.
I remember my last shop had I inherited this space, and it was in a basement with no heat and no ventilation.
Nope.
Yeah. That was brilliant.
Jens, we're at 55, so let's get started.
I was going to say, let's get started. So greetings, everybody. Welcome to Ask the Expert, Episode 6, Water, Hardness, and Specialty Coffee. My name is Clinton Hodnett, and I'll be your moderator for this episode. Today, we're talking with Scott Manley from La Marzocco. Scott has prepared a presentation for us, after which we'll open up for questions, probably about 20 minutes or so. I'll be collecting those questions for Scott as we go, so please feel free to drop them in the chat box. We'll also provide listeners with contact info if you have any further questions or comments for Scott. This Ask the Expert series is for everybody. Our first season of 8 episodes, we've covered a wide range of topics. Our second to last episode next week will be First Year as a Tech with Christopher Brown. Make sure you save next Friday at this time, whatever it is for you, for the Coffee Technicians Guild. With that, I'd like to introduce Scott Manley, Technical Support Supervisor at La Marzocco and General Water Wizard. Scott, the floor is yours.
Thanks, Clinton, for the introduction. Wizard, I like it. So, as you said, Scott Manley, water quality specialist, not expert, but a lot of experience. So, I work for La Marzocco in Seattle, Washington, and does everybody have a cup of coffee? I know I can't hear you, but I'm going to give you a moment if you need to go grab one. Are we good? All right, let's get started. So, water hardness. This is the subject we'll be covering today, and hopefully I can give you some quality information that you can use as you go out and service equipment. It's probably something that the majority of technicians are going to encounter unless you're in a few select areas that only have good water. And we're going to be discussing today how to identify it and how to test for it, like basically what it is. So what is water hardness? Well, generally it's the amount of dissolved calcium and magnesium in water. It's specifically the anions in water, cations in water, I'm sorry. Calcium, magnesium, and a few others, but those are the majority or predominant cations you're going to find in fresh drinking water. When hard water is heated, such as in a boiler, solid deposits of calcium carbonate form. That's the scale that we see, the stalactites. It looks like the inside of a cave. And without proper treatment, this can result in repeated service calls for technicians to descale equipment. So when we talk about water hardness, how hard is water? What does that mean exactly? Because we often see that thrown around in relation to other numbers with our water, like for instance, TDS, which in the last series we discussed often gets confused or conflated with other parameters in our water. So let's put some definition around that and talk about, well, what is that? What's that look like? So soft water technically is water that really has very little hardness at all, and that would be 1 grain per gallon or less. That's probably almost not anywhere that you're going to find that as naturally occurring water or in a municipal water system. That's like practically distilled water. Slightly hard water, 1 to 3 grains or 4 grains per gallon. That's going to be water that you find in some large metropolitan areas like Seattle, Portland, and New York City. Places where espresso machines thrive with very little water quality problems. Moderately hard water is probably the predominant 40% of the water you're going to encounter out there, and that's 3 to 7 grains per gallon. It's water that does technically fall within the SCA's and many manufacturer specifications, but you're still going to see some scaling with that. There are other parameters in your water that are going to affect that, and we're not going to discuss all of those right now, but just know that in that range, you probably can look at some light, remediation or abatement technology, filters to deal with that. And then we get to what is technically hard water, 7 grains and above. And this is stuff that's really going to scale your boiler pretty quickly. Above 7 grains, you can expect that you're going to be seeing a reactive service call in new equipment at least in the first year, maybe in the first 6 months. So that's going to be a real nuisance, and it's going to be a cost driver for a cafe's equipment maintenance. So, and that's going to be like in the U.S. at least, that's 70% of the water falls into that range of hard water. And then very hard water above 10 grains per gallon. That's beyond nuisance. That's just that's water that no equipment's going to survive in without any kind of treatment or technology to deal with that. It's also, your coffee's going to taste like chalk, because when your water hardness is that high, you're generally going to have very high bicarbonate or alkalinity levels that go along with that. So something to note. So a note about measurement and how we define, or how we units that we use to define water hardness. And if you've used some of the test kits already available on the market, maybe from industries outside of coffee, or freshwater testing, you'll see for pools and aquariums and things like that. And they use many different gradients or units for measuring water hardness. And they all basically relate to one another, but it can get confusing when trying to do the math, converting one system to the other, so that you can understand relatively what you have in your water. So for the purposes of presenting this and presenting to coffee technicians, we're going to be using parts per million, which is defined in CaCO3 equivalency or calcium carbonate equivalency in fresh water. Alternately, it's in grains per gallon, which is pretty easy because you can convert that by just simply 1 grain is equal to 17.1 parts per million. More than likely, your drop count titration kits are going to use grains per gallon, just because it's an easier, simpler way to make that process work in an efficient manner. So we've talked about kind of degrees of water hardness and what that looks like in terms of a number. But let's talk about 2 different types of water hardness that often get brought up, or I hear in the conversation. The first being temporary hardness, caused by calcium and magnesium bicarbonates in your water. This is the hard water scale. This is the thing that precipitates out and causes all your problems. It's the things you're going to spend most of your time trying to deal with. The second one is referred to as permanent hardness, and it is compounds of calcium and chlorides or sulfates. This gained some traction a number of years ago in remineralization systems. I'm not calling anyone out here, but the idea being, well, great, you've got this permanent hardness that does not scale, basically. You can have a high calcium concentration and high mineralization in TDS, but you don't have to worry about it building up in your boiler and clogging things up and creating reactive service calls. It's also easier to deliver and dose into your water system because it can be put into solution easier. The problem with that, though, is that if you look at it, both of these compounds, be they temporary hardness or permanent hardness, are both chemical compounds. and mineral compounds. And they aren't calcium bicarbonate or calcium chloride in water, because water being a polar solvent, it dissolves these things into their constituent analytes. And so you basically, with permanent hardness, you're just putting a bunch of chloride into your water, which probably isn't a good idea. Another way to put it, but to compare the two in a visual, is nuisance versus new boiler. Whereas temporary hardness, which does precipitate out, will do something like this. This is the inside of a steam boiler, and what it looks like on untreated hard water. And even moderately treated, moderately hard or moderately soft water, if, you know, over a period of time, it's left unchecked, it's going to build up like this, because in the steam boiler, it's just going to concentrate. All the water boils out, everything's left in there over time. So the second picture, of course, is that's permanent hardness. That's chloride pitting corrosion in metal. The chlorides, of course, would be free in the water and would be free to bind with the ferric iron in the surface of the metal. And eventually it will create, you know, if conditions are right, you know, pH is low enough or there's not enough alkalinity in the water, it will create a pit, which is an autocatalytic reaction, which will eventually burn a hole through the boiler, like you see in the picture. While you could have permanent hardness in your water and not have it attack the boiler, the only way to do that is to raise the alkalinity so high, because alkalinity or bicarbonate is a competing anion for chloride, that it buffers the ability for the chloride to shift the pH down in that micropit. Unfortunately, that's a lot. That's going to be a lot of alkalinity. It's like 200 parts per million, 150, 200 parts per million. Your coffee's going to taste like chalk. So from a flavor profile standpoint, it's just not going to work. So I guess the question is then, you know, if we talk about different types of water hardness, we talk about different degrees of water hardness and what those numbers are, well, then the obvious next question usually in the conversation is, well, do I have hard water? You know, is this what, as a technician, what I'm dealing with, is this what I'm seeing? Fortunately, it's pretty easy to test for hard water. This is being, you know, the most common thing people deal with. There's a lot of testing options out there and solutions, and I'm going to run through a couple of those that I've used or have identified as being the most accessible for coffee equipment technicians in the field. Now, there are some other options like testing labs and more expensive equipment, but most of those are kind of hard to get a hold of or hard to bring around with you when you're on the job. So I think the first one that most people are going to be familiar with are test strips. These are easy. I mean, you can keep them in a small plastic jar in your tool bag. They're ready to go. Not too expensive, and you can, if you run out, you can order more, or you can even get them at like Home Depot usually. So the advantages to these things, they're simple and convenient, and they're easy to use, and they are actually fairly accurate. This is where I and most people start out in their, you know, water testing journey as technicians. Is somebody probably handed you a bottle of these, like a supervisor or a boss or somebody, and said, here, keep these with you, and if you need to, test the water. May have not discussed when that's appropriate, but at least, you know, they started you off on that. That was my case. A couple of things you learn about test strips, though, is they can actually be kind of expensive per test for the relative accuracy and precision that you get. And that has to do with the fact that the reaction that they have in the water isn't stable. So you've got this time frame where you've got to swirl this around in the water, let it sit, and then watch it. And I don't know about you, but in a cafe, and if it's a working cafe, it's pretty busy. It's easy to get distracted. There's someone to come up and you know, say, excuse me, I see you're working. Can you, you know, and that's all it takes, because you get like 10, 15 seconds or something. So that's one of the downsides. They're not very precise. So you can see on here in the gradient, it's on the side of this bottle in the graphic. It basically tells you if you're in trouble or not, but it doesn't tell you how much trouble. And it may not be enough information to use when you need to present to a customer, well, here's what I think we should do with this. Here's where I think the problem is, and here's what I think we can propose as a solution. You're probably going to have to do a little bit more testing or get more information to make that, relevant. The other issue with these, and I learned this doing a presentation a number of years ago, was that, well, it's colorimetric, right? You have to see a color change. And I was leading a class of about 50 people. This is at Expo 2017, or yeah, Expo? Yeah, anyway, SEA event. And I think 2 people in the class raised their hand and said, but I'm colorblind. And I hadn't thought about it. I really hadn't considered it. But it's a concern. And I've had a number of people bring that up to me. What do I do if I can't see the color change? And you don't even have to really be colorblind necessarily. It can be hard to actually just see the change and compare it, even normally. So that's a consideration there. Probably the next most common thing, and the thing that I kind of landed on as a field technician, was manual titration. And the advantage there is that you do get a little bit better precision. You can better define the results that you're getting. The cost per test is actually a little bit better, given the accuracy, than the dip strip. The other advantage is it ends in a stable reaction. So, and this question came up from a guild member just the other day on the Slack channel. When you're adding titrant to your solution and the instructions say wait for the color change from purple to blue or something, oftentimes you'll add a few drops, and at like the 3rd drop and you're swirling it, it will change color. And if you wait a moment, it will change back. So where do I read that? Well, since we know that it ends in a stable reaction, we want to add titrant in drop count until that color change is permanent. And we count the number of drops up until that point. So hopefully that clears that up. Some of the cons, it's easy to mess up. A lot of human error, right? Did I add the right amount of reagent? I've done this before. And in a busy cafe, just like with test strips, you can be interrupted and distracted really easily. So I like to do this sort of thing in the back room. Also, because for some people, it's really interesting to watch you play chemist. And for other people, it's really scary, it turns out. So again, another con would be that, and it's messy. I mean, I don't know how many times I've actually knocked something over, or somebody's walked by me and I've moved out of the way and knocked my stuff over on the counter. And again, it's colorimetric. So it's dependent upon being able to see the color change. And I've even found myself in some cafes that are either dark or have odd lighting that it can be a little hard to tell, So there's that. Metering devices. So these are handheld photometers. The iDip is one, and I know there's a lot of guild members, a few guild members that have used these. I don't have personal experience with them, so I can't really speak to how well they work, but I'd be interested in trying one. But they do multiple parameter tests, and hardness being one of them. The advantage to a handheld photometer is that it is a bit more accurate and a bit more precise, because the color change that's occurring is actually being measured by a device that kind of removes it's going to remove the subjectivity out of the tech or your eyesight out of that, and the lighting environment that you're in. Cost per test is generally pretty low. With the iDip, I think it's pretty similar though to test strips, because that's what they use to get the reagent into the solution. But for things like the hand on the right, the cost per test is pretty reasonable. Downsides are going to be upfront cost. Both of these meters are going to cost a couple $100s. It does add a bit of complexity into your toolkit. I mean, we're all tool geeks, but at the same time, we got to get in and out of our locations. We may have to walk several blocks. I used to work in downtown Seattle and would have to find parking and walk 6 blocks and go up 8 flights of stairs or an elevator. And so it's just one more thing you may have to carry. So, and it adds a little bit more complexity to a workday. The last one the tech could carry is a TDS meter. And if you're on my webinar about TDS meters, you know that people often conflate the underlying analytes with total dissolved solids. However, in the case of water hardness, where it tends to be the predominant analyte, the predominant issue in water, and in many areas it's the only thing. Matter of fact, where a good majority of my work career as a field technician, all I really dealt with was hard water. Most of what was in the water, all of the TDS was hardness. And I knew this from testing and experience and other information. So for me, it was easy enough just to use a TDS meter to get a rough idea if how hard of water I'm dealing with, how much of a concentration of hardness do I have. Also, it's convenient if you're using something like an RO or a nanofiltration system to remove hardness mechanically, because you can easily compare the concentration before and after the system with a TDS meter, and you're not having any ongoing costs for reagents like you do with the other three tests. So it can be useful for water hardness, with the caveat that you need to know that you have water hardness before using it. So those are the four primary things. There are other types of photometers and mobile systems, but they all get a bit more expensive, and that increases the cost, complexity, and risk for the technician. So I didn't really include those. So this short webinar, and I can't believe it took me 20 minutes to get through that. It seems like it was 4 minutes, but what we're sharing today is just a brief hit on this subject, just an introduction. We really don't have the time to go into, at least in the presentation side of it, all the different ways we might be able to deal with hard water. But if we've got questions and afterwards during the Q&A, bring them forward, and we may actually roll this into another, future series, future episode where we actually talk about, well, now that we've identified hard water, we've tested for it, we know we have, how do we do something with that as a technician? So I look forward to being able to share that sometime in the future. And with that, we're at 20 minutes, and I'm going to throw it up for Q&A time.
Well, a few of the questions have given you the opportunity to talk about that a little bit already. Okay. So first question that came in was from Carl Dube. Total hardness or carbonate hardness, measure one, both?
So total hardness is the measurement of, or the sum of, your calcium and magnesium in solution. And carbonate hardness is really your alkalinity. They are actually two separate things. This is sort of confusing in chemical notation because in order to compare analytes and water, we have to have some common denominator, some common mass. And for fresh water testing, we use CaCO3 or calcium carbonate. It's easy because to convert things to that, because calcium carbonate is approximately 100 grams per mole. And I'm not a chemist, and I will screw this up. So most people with high school chemistry know this better than I do. But essentially, we convert those numbers to CaCO3. It does not mean that they are CaCO3 or that the test is the same, because I've had that argument. But it just means that there's a way to compare apples to oranges or grapes to grapefruit or whatever sort of thing. You know what I mean? Because otherwise, you'd be saying in relation to total hardnesses versus general hardness, carbonate hardness, you could have equal numbers of those, right, in water. And so there has to be some way to compare what is the relative concentration of each. Sorry, I muddled that a little bit, but yeah.
No, great answer. Will a softener work for both permanent and temporary hardness? That one's from Caleb Leach.
Yes, it actually will, because like I said, the compound, either calcium bicarbonate or calcium chloride in the in solution in a polar solvent like water is going to be calcium and the other thing. And an ion exchange softener only anion exchange softeners or cation exchange softener is only going to remove that cation in the water, which is your calcium, and leaves everything else. chlorides, bicarbonate, all that pass right through a traditional sodium or potassium water softener.
Gotcha. Okay. From Highland, what does it mean if you have different colored buildup on the machine, like black or blue? The picture you showed a lot of white, but sometimes we get to see some funky colors in there.
It depends on a number of other minerals that are in the water. So you could have, your water can pick up some copper from pipes or other, just naturally in the water. And that, of course, is also going to somewhat get bound up in that scale. Black can be carbon and or iron. If it hasn't really iron, if it's not been exposed to much oxygen in the water, it looks black, although typically it's slimy. And probably a few other things that, while they're not very dominant in fresh water, probably do add quite a bit of color to those stalactites in your boiler. I've seen an entire rainbow, man, of stuff over the years. Most of us have.
Yeah. I just opened up an E61 cap and it was a lovely green tinge through the whole thing. And Buffalo likes to dump a little extra chlorine in the water every so often if Lake Erie acts up. So I assumed it was kind of just, well, we went past the filter a little bit. We'll clean that up. That's okay.
Yeah. Well, an important note about that is that the chlorine necessarily doesn't generally, I mean, it dissipates pretty quickly from water, although a boiler is a closed environment. When you pass chlorine through a carbon filter, activated carbon filter, it basically doesn't absorb chlorine. It actually reduces it to chloride, though not very much, not a significant amount. But I suppose if you had a cafe that was really close to a distribution site for water, like a pumping station, and they did they flashed the system with or shocked the system with chlorine, I suppose it's possible you could overload a chlorine filter or a carbon filter and dump a bunch of chlorides initially through the system.
Okay. One for me, actually, you use the term reactive surface right at the start. What can kind of be allowed? Like, what's the definition of that? Is there like a certain thickness? And then what can be allowed as buildup? And then when should we start to be concerned? If I'm starting to see this much hardness buildup, it's time for a descale versus, well, we can let that go for a little bit longer.
Yeah, it's an interesting question because, for a long time, like for instance, La Marzocco, I know, and some other places I've worked have talked about, well, what's an acceptable amount of scale? Because we usually define it as, well, we don't want water that's too clean, because that in and of itself could mean that you've got some conditions in the water that could lead to corrosion, right? So really clean water could probably have a really low pH, which in and of itself isn't bad for an espresso machine per se. But it creates an opportunity. If the water chemistry shifts, then you might have a problem. So we've always erred on that side of, well, a little bit of scale is good, a little thin protective layer, so to speak. And I know that's messaging from La Marzocco for years. The way I would define it is that, some scale is okay and some water hardness is all right, as long as it's not creating reactive service calls over, I'd say, at least a 2-year period. Some people say 5, which is pretty long. A lot of equipment isn't even in the field for that long. But I would say if you're out there every, more than once in a year, for sure, you really need to revisit whatever that regimen is or whatever it is you're using to deal with that. So although it's, you might have seen in my slide there, I crossed out, residual income, but there's a certain truth to that. You kind of can get into this habit of just going out and scraping out boilers. I know I did for a while. So.
Got some requests for a future seminar on treatment. So I think we should definitely
absolutely
work that in there.
And that's an interesting one as well, because much like testing equipment, more than likely, depending on your water quality, you may have options. There's maybe more than one right answer to that, and it's all going to be dependent upon a number of factors that all have to be considered when presenting something to a customer or making a decision about your own cafe. So that one in of itself is a fascinating subject.
Definitely got some very specific questions in here about that kind of thing. So I think
But
we'll take our time on that one for sure.
yeah, sure.
Some of the simplest ways to reduce hardness, like softeners, or is there something else?
Yeah, I mean, if you're just trying to reduce hardness, an ion exchange softener is probably the easiest, lowest maintenance, lowest energy water usage. But it's only an option if you take into consideration everything else that's in your water, because generally when you have really high hardness in water, you also have really high alkalinity as well, most of the time. And an ion exchange softener is only going to take out the hardness and leave all the alkalinity, which isn't necessarily bad for your equipment. But 200 parts per million of bicarbonate in your water is a lot of bicarbonate. It's really going to mute the coffee a lot, especially in batch brews where you've got this larger ratio of 17, 18 to 1. Yeah, you're gonna notice it.
And that actually brings us to a few questions here about where's the right spot for hardness for coffee taste, and how does being either side of that affect the flavor of coffee, either very hard or very soft water?
Generally, when we're talking about how water hardness is affecting extraction, I think that from my own experience in both treating water and working in the coffee industry, I think the majority of our subjective perception on the effects on extraction tend to resolve around the bicarbonate or alkalinity, whereas the hardness does play a part in extraction. The more obvious thing that's going on is the alkalinity is muting the acidity. And this is true as coffee. You know, I grew up in Seattle. I'm from Seattle, Washington, where dark roasts tend to be prevalent, and that may have something to do with the water. We've got really low TDS, very soft water, not a lot of buffer in it. So if you have a lighter roast where you've got a little more acidity in that coffee, it's going to be very bright, maybe even very sharp. So the roast is kind of muting down that acidity. But if I was in an area where I had harder water that I was cupping, right, I may go to a lighter roast because I can mute some of that acidity in the roast, the acidity part, but then bring out different flavors, right, and different experiences from that coffee that otherwise couldn't if the water was softer. So that's really more of a subjective thing. And you know, at the La Marzocco Cafe, where we did roasters in residence, we had roasters from all over the world, and sometimes they would bring coffee in and they would cup and they would, you know, kind of get prepared for that next month, and they would say, wow, my coffee's really bright in this water. Is there something we can do about it? And you know, or as an example, or likewise, customers who come to Seattle and maybe, you know, for a vacation, they go to one of the classic roasters that maybe do a little bit of a dark roast, and they take that coffee home or they order it and they go back to wherever state they're from, and the water's much harder and they don't soften it or remediate it, and they you know, dark roasted coffees in really high alkalinity water is really not pleasant personally. So as you know, saying that there's one right water or one correct water chemistry for brewing is a little difficult, because that's the subjective part of it that comes into it. I suppose, you know, we can quantify some of that by using a refractometer and looking at extraction yields based upon water quality, and that would give us a little more concrete information to make comparisons on. But I don't think that would necessarily tell us something is actually, I don't even know if that's still actually correct, right? So.
Chuck wanted to add, from personal experience, the iDip Exact is also sensitive to the light inside the cafe while you're testing. If you're in a dark cafe, it won't give you an accurate reading, so usually he walks outside with the meter. And I can add with dip strips, I've found the same thing, where if I've got, like, if for some reason they have a really warm, wonky light above the bar, my dip strips, I've walked to the other end of the bar and been, wait, getting a different reading here. So the lighting is definitely important when you're testing with almost any.
That may be the difference on the iDip, and I've heard similar comments to that before. I haven't used one, so I don't know. I assume that they have their own light source, but my guess is that they don't, and that they rely on natural light. Whereas the Hannah in the other picture in that slide actually seals and has its own light source, so that it's using the same light source every time. That probably increases its consistency quite a bit. I have several Hannah instruments in our water lab, and I can speak to their accuracy. So that's probably where that difference comes in. So.
Are grains per gallon and TDS directly related or separate measurements? Meaning you can have 1 grain per gallon and say 250 TDS.
The same analyte? No, not hardness. No. You either have. I mean, it's just a simple mathematical relationship between the two. They're both going to end up with the same actual mass concentration either way. It's just a different way of quantifying it.
And it's 1 grain per gallon is about 17.1 parts per million, right?
Yeah. I just round it to 17 most of the time. I mean, that's the level of precision beyond that's not of terrible concern. So.
Few questions about water temp. Using water straight purged from boiler water, is that okay? Is that going to affect the accuracy of the test?
Generally, when we're testing for water, we're not testing the water after it's gone through the equipment. We prefer to test the water, the source water where it's coming in, right? We want to know what it is we're going to have to deal with, because the water as it goes through the boiler is going to be affected by the fact that it's, it is heated, it is concentrated a little bit. It's not going to give you I mean, you can pull water out of a steam boiler and it's like 700 parts per million. And if you were basing your purchasing of water filtration products based upon that number, you would probably spend way too much money, or not. You need, so when we're testing water, we're always testing the source water before it's filtered. Even if you're at a location that already has a filter, you want to test and get an idea of what it is you're dealing with. And then that tells you, well, is the filter that's here, is that appropriate? And then you can take the next step from that and then see, well, can I test to see if this filter is working? Does that make sense?
Yeah. Does temperature affect it though? I have a few clients personally who, before I got there, had hooked up machines to the hot water line. Mm-hmm. So sometimes I have like 5 seconds of water that I could get that's about room temperature, and then all of a sudden it's much warmer, and I've never been sure if that would be an accurate test amount, or if.
You mean coming out of the machine?
No, they've put a water line from the hot water tank in the space and fed the machine with that. Yeah.
I mean, you can. I mean, that is a thing you can do. I mean, we used to at Starbucks, we used to put these small, like 4 and 6 gallon Bosch point of use water heaters in line to the espresso machine. Those have glass tanks, but the domestic water heater has got an anode in it, and so it's not really, you're not supposed to drink from it. So that would definitely, yeah, you're gonna have to find like a hose bib outside or something, or a mop sink or something to test the water. Honestly, anywhere, any of the water that's untreated in the location that's cold water, that's, yeah, fair game for testing. Do be careful on hand sinks though, because sometimes you end up with tempered water and you get some blending that goes on, and that can throw it off. So I usually recommend something like a mop sink or a dump sink that's less likely to be tempered.
Let's see. How does water hardness interact with the pH of the water?
Well, because most hard water, like I said, as a component is going to also have roughly equal and closely equal parts of alkalinity. Alkalinity is not the opposite of low pH or acidity. It's just the ability of, it's the buffer. It's the ability of waters to maintain a consistent pH that doesn't shift around. So yeah, certainly if you raise the saturation level of your bicarbonate in water, it's going to eventually, and because calcium and magnesium are alkaline metals, they're going to eventually raise the pH of the water up somewhat. It's often another way to think about it, though, is, and you may have noticed I did not bring up saturation indexes like Langelier or RISNAR, which has been sort of a common thing to use. Like, well, if I put this information into this calculator, it'll tell me whether it's going to scale or not. You really don't even have to do that, because it's not going to tell you, and you can't input filters into your water to manipulate the water to change either your RISNAR or Langelier, because in order to do that, you're going to have to force the water into basically an unnatural state. Langelier and RISNAR also are used primarily for process or like large cooling towers or boiling waters, where you can put things into your water that you don't drink. And that's the challenge for us, is that we're dealing with sanitary boilers that you're actually consuming the water out of. And so while those indices can be sort of helpful, I've kind of shied away from communicating them, because it sort of gives you this false idea that if I can just shift these numbers, if I can change the saturation point of the water, I won't get scale. In order to do that with really hard water, though, you've got to radically be able to drop the pH to do so.
This one seems like it's a specific brand, but doing a quick search in the background here while you talk. Stylophobe, it's some kind of scale inhibitor, I think in 3M filters. Asking your opinion about that. Stylophobe, I might be butchering that. It seems like, I know Everpure has the scale stick, and I'm guessing it's similar to that.
Well, a scale stick from Everpure is a polyphosphate, which is a chelating agent or a binder. So it works to sequester that the calcium's ability, free calcium in water's ability to stick to things. It sort of turns into sludge, basically, in the boiler. They're great for like ice makers and things like that, but once you've heated up the water, and especially in an espresso machine, the issue there is that the polyphosphate tends to come out of solution at about 200 degrees. So while you won't have hard scale, it'll certainly make cleaning the boiler easier. You'll end up with a bunch of stuff in there that you're still going to have to remove.
It's actually how I became a tech, is shop put that on, and when the heating element dry fired, I was asked if I knew how to fix that, and I have polyphosphates to thank for this career. Any suggestions for scaling a water testing and filtration program on a national level?
You mean something like guild level, like where we could all kind of, or?
Keegan, if you want to qualify that, we can swing back to, I'm guessing it's more for like standardizing along a chain.
Oh, okay. Well,
kind of thing, but
I think what I've always emphasized, and this is just from my own experience, and I worked for a large chain. I worked for Starbucks Coffee Company's retail store development for 10 years, and I was with Starbucks for 16 years. And for my area that I was in charge of, the thing that we learned from was simply having the testing be a part of every service visit. Having some way to record that and document it, and then being able to look at what happens in that water over time. That's the most important thing to do, is just to gather the information. So however you accomplish that, if you're using paper work order forms, just add a section on there to have that recorded every time, or if you're using an app, if you can add some entry to that data field so you can record that information. That's the most important thing. Not necessarily which one of these test measurement systems you're using, but just getting out and using it. And that's true of most types of water testing, is that the more you use it, the more familiar you become with it. And that's an important factor, because in analytical chemistry, you have to enter into the testing regimen with some expectation of what you're going to find. That doesn't mean you assume you're going to find something, but you have to know kind of an idea what you should be looking at, so that when you get an erroneous result, it becomes apparent. Like if you've done this 100 times and you get one that's a real outlier, there may be a reason other than it's just an outlier. It may be something you'd missed in the test, or there's maybe something else you need to look at. So for implementing this on a larger, broader platform, like within an organization, I recommend just getting started on whatever you do, and start now, and start with the two things: testing in some manner, documenting on the other.
When the hardness is too low, how can we increase that?
That's an interesting question. Remineralization. So that's a tricky one because water's, that's a hard thing to do, to be honest, and do it in a controlled manner. There are two principal filters or filter media that's used to remineralize commercially. The first being calcite, which is just calcium carbonate. That's the hardness that you see in your boiler, and you would put a filter in line that the water, when coming in contact, will absorb some of it, known as calcite. Calcite filters are great because they're really consistent, or generally consistent, meaning that their output versus flow rate stays approximately the same. It doesn't shift up and down a lot because it's not terribly soluble. The second, and so if you had really low hardness water, like RO water, you're only going to get like 40 ppm total hardness coming out of it. That's about it. Which is, a lot of people want more, but that's probably what you're looking at. There are ways to increase that or to bring it up a little bit by changing some of the plumbing and flow rate and adding an accumulator tank. But that's about it. The second one is magnesium oxide, or Magox, or Corasex. Those are all the same things, and those are generally used in industrial water applications to raise very low pH water up. It can also be used to remineralize coffee, and a lot of people subjectively think that magnesium creates a better extraction or a more pleasant brew, a little more mouthfeel, that sort of thing. And it does. It will remineralize quite a bit more at nominal flow rates for an espresso machine. You can see, and I've tested this with a number of filters, magnesium oxide will remineralize water into the range of 80 to 100 parts per million. It does have one downside, though, and it's a bit more soluble, and it will over mineralize pretty easily. Most of the manufacturers of these cartridges will, in their instructions, will tell you that every morning you need to flush the first liter of water out. And I can say from experience that that's true. When testing that first liter of water in the morning, the water that's been sitting in the cartridge all night, not going anywhere, the output's like 400 parts per million or 500 parts per million. Now it's magnesium oxide, so it's probably not going to scale your boiler. But I kind of wonder how much of an effect that's going to have in the morning if you're dialing in. And if you have an accumulator tank and maybe some pressure control after that, you may end up with much higher TDS. And it's more of like, what is that going to do to your extraction? So, yeah.
Gonna have time for one last one, and there are still plenty of questions coming in here. We will make sure that all of those are answered through our Facebook. But one last question for you, Scott, before we wrap up. What is the effect of hardness and TDS when the barista uses an espresso machine like a hot water boiler? And I think what they're referring to is using the T-tap as a hot water source.
Oh yeah, T-tap or economizer on espresso machines. Of course, generally you're pulling water directly from the bottom of the boiler via a siphon tube. And yeah, you're going to have the concentration of whatever's in that boiler, generally pretty high TDS water. Great for rinsing things, not a problem. I mean, yeah, if you're using it for your tea or even Americano, I'm assuming it's going to have some effect on it. It's going to, impart some sort of subjective flavor into that brew. Generally, though, it's better to have a standalone boiler for that.
Given that that's evacuating some of that mineral content out of the boiler, is it a good idea to use that T-tap regularly to kind of purge the boiler?
Yes, absolutely. I think, and a lot more manufacturers are looking at how to incorporate that as more of a feature design. And then some manufacturers have done really well at even having internal flushing systems that purge the boiler at regular intervals. So yeah, no, that's a great idea.
All right, well, we do have to wrap up for now, but like I said, if your question went unanswered, we will do our best to answer them through our Facebook or as some kind of a handout. But thank you, Scott, for your time and all of your knowledge. I've got a page full of notes here myself, so this has been really wonderful.
This is fun. Thank you, guys. I look forward to seeing you guys in the next one.
All right, take care.
Take care. Bye, everyone.
Thanks, guys. Have a good weekend.
You too. All right.